So, picking up where we left off with number 11 of the review problems. In a certain instructor's class, homework is worth 25% of the semester grade, a research paper is worth 15%, and the two exams are worth 30% each. If a student gets 95 on homework, 55 on the research paper, 60 on the first exam, and 72 on the second exam, what is the student's weighted average for the semester? So here we have to calculate the weighted mean. There are 4 scores here: a homework score, a research paper score, a first exam score, and a second exam score. And those 4 scores all have their own weights. 25% for the homework, 15% for the research paper, 30% for the first exam, and 30% for the second exam. So the way we calculate the weighted mean is we take each weight times the number that it goes with and add those together. So that would be 0.25 or 25% times the 95 homework score plus 0.15 times 55 for the research paper plus 0.30 times 60 for the first exam plus 0.30 times 72 for the second exam. And then after doing that calculation, we should divide by not how many numbers there are, not for a weighted mean, but by what the weights add up to. Here, the weights add up to 1, because together they make up 100%. So we would just be dividing by 1. So when we do all of this calculation, we get a final answer of 71.6. Your weighted mean should always be somewhere in the middle of the numbers that it's the weighted mean of. If you get a weighted mean that's below all of these scores or above all of these scores, you did something wrong. Number 12. 20 people were asked to name their favorite member of the Three Stooges. The following replies were obtained. So, some people like Curly, some people like Moe, some people like Larry. One person voted for Shemp. And because I have been asked about this, Shemp is the replacement for Curly. When Curly had to retire for health reasons, he was replaced in the Three Stooges by his brother Shemp. So anyway, we have these 20 names, these 20 qualitative data values, and we're making a frequency distribution where we list for each one of these what's the frequency. That is, how many people gave that response, or how many times does that particular value appear on our list of responses. Here's what that looks like. 10 people said Curly. There are 10 Curlys on our list of data. 5 for Moe, 4 for Larry, and 1 for Shemp. And if you add up those frequencies, they do add up to 20. And then for the relative frequencies, here's how we calculate those. We take each frequency divided by how many there are in all. So for example, 10 divided by 20 would be 0.5. And then to convert that from a decimal to a percent, we multiply by 100, which is really just a matter of sliding the decimal point over 2 places to the right. So 0.5 as a percent would be 50%. And 50% is half. Half of the people, 50% of them, said that Curly was their favorite member of the Three Stooges. The other percents were 5 divided by 20 is 0.25 or 25%. 4 divided by 20 is 0.2 or 20%. And 1 divided by 20 would be 0.05 or 5%. And the percents do add up to 100% in all. Here is what a pie chart would look like. We draw a circle, And then since one of the categories is 50%, that takes up exactly half of the circle. Then if we divide the other half in half, this quarter circle would be 25%. And then the remaining quarter, if we divided it up into 5 equal sectors, one of those would be 5%, and the other would be the other 20%. Then I just labeled each section of the pie chart with what it refers to, the name, and the percentage. And then a Pareto chart would look like this. There's one bar for each response. They are labeled in order of frequency. Even if they weren't listed in order of frequency here, to be a good Pareto chart, the bars do have to go from highest to lowest. And we do need a consistent scale for the frequency. So we've got 0 at the bottom, and then we have the same amount of space going from 0 to 1, 1 to 2, 2 to 3, 3 to 4, and so on. So if you were drawing this on lined paper or graph paper, use the lines on the paper to label your frequencies. And make sure there's the same number of lines between 0 and 2 as there is between 2 and 4, 4 and 6, and so on. 10 is twice as big as 5, so the bar for 10 should be twice as tall as the bar for 5. Number 13. In a class with 8 people, a quiz was given and the following scores were obtained. So here's this list of 8 quiz scores. And it says this was the whole class, so consider this a population, not a sample. This is everybody we care about. It's not just a representative sample taken from some larger group. First, what is the mean? Now, some of these things I'm asking about in this question, things like the mean, the median, the standard deviation, are things where you could enter these numbers into something like a calculator or a spreadsheet and have it give you the mean and the standard deviation and so forth. If you know how to do that and want to do it that way, you are allowed to do that on the test. That's what I would do if I had lots and lots of data. But on the test, I'll keep things simple enough where you don't have too many data values and it doesn't get too complicated, where you could just work through the steps yourself. So that's what I'm going to be showing you now, how to work this out for yourself. So to calculate the mean of a set of numbers, you add them together. So these 8 numbers add up to 200. Then you divide by how many numbers there are, which is 8, and that comes out to be 25. And it came out to be 25 exactly, so we didn't have to worry about rounding, but if you did have to round, the rule is give one more decimal place than the original values. So that would mean that we would want the answer to the nearest tenth, to 1 digit after the decimal point, if we had to round it. B, what is the median? So do you remember how we find the median of a list of numbers? Start by arranging them in order, like from lowest to highest, 18, 21, 23, 25, 27, 28, 28, and 30. And then the median is what's right in the middle. If there were an odd number of values here, the one in the middle would be the median. But since there's an even number of values, the midpoint is halfway between 2 of these numbers. The 2 in the middle are 25 and 27. So halfway between 25 and 27 would be 26. And that's pretty obvious, but if you had to, you could add them together and divide by 2. So the median is 26. There should always be the same number of data values that are less than the median as there are greater than the median. So here, 4 of these numbers are less than 26, and 4 of them are greater than 26. What about the mode? That's the most common value, the value that appears most often, and here that would be 28. There are two of those and only one of anything else. What is the range? So that would be where you take the highest minus the lowest. 30 minus 18 is 12. Now, what are the variance and the standard deviation? This is a population, so that will affect how we calculate the variance and standard deviation. So first we'll do it based on this being a population, and then we'll talk about what the answers would be instead if this were a sample. On the actual test, I might give it to you either way. I might say this is a population, or I might say this is a sample. So you should know how to do it either way. So remember how this works. To find the variance and standard deviation of a list of numbers, we need to know what the mean is, and we found that earlier. That was 25. And the first thing to do is take each number minus that mean. 27 minus 25 is 2. 30 minus 25 is 5. 23 minus 25 is negative 2. 28 minus 25 is 3. 21 minus 25 is negative 4. 28 minus 25 is 3. 18 minus 25 is negative 7. And 25 minus 25 is 0. Then we square each of these numbers. And remember, when you square a negative number, the result should be positive. So make sure you write all positive numbers in this column. 2 squared is 4. 5 squared is 25. Either a negative or a positive 2 squared should be 4. 3 squared is 9. 16, 9, 49, and 0. Then we add these numbers together. They add up to 116. Then the variance would be 116 divided by how many numbers there are, which is 8. And that comes out to 14.5. So that's the variance. And then to get the standard deviation, we take the square root of that. The square root of 14.5 is 3.8. Now, if this were a sample, once we get to this point, we would divide the 116 by not 8, but 7. One less than the number of values we have. So 116 divided by 7 is 16.57 something something. So that would be the sample variance. And then the sample standard deviation would be the square root of that. Square root of that number comes out to be about 4.1. And finally, what is the z-score corresponding to 21? You calculate the z-score for a number by taking that number minus the mean and then dividing by the standard deviation. So here that means we're taking 21 minus 25 and dividing by 3.8. And remember, when you put this into your calculator, you're going to have parentheses around the 21 minus 25 so that it doesn't do the division before the subtraction. It's first you do the subtraction, then you divide, and it should come out to be negative 1.05. Here's what it looks like on the calculator. Parenthesis, 21 minus 25, close parentheses, divided by 3.8 is negative 1.052 something. And for z-scores, we like to give 2 digits after the decimal point. So to the nearest hundredth, that would be negative 1.05. Okay, that seems like a good stopping place. I will stop this video here and pick up where we left off in part 3.